Good day. Today we'll be looking at separation of mixture and purification of chemical substances. The learning objective of this topic: at the end of the lesson, students should be able to, number one, distinguish between pure and impure substance. Number two, identify the criteria for the purity of pure substance. And number three, to specify the principle involved in each separation method. So pure substance and impure substance. So here we're looking at what is a pure substance and what is not impure substance. So pure substance. A pure substance is a substance that comprises a single type of atom or molecules. It contains constituents of its own molecules only. So examples of pure substance are elements and compounds. So all elements and compounds are what? They are pure substance. What's the next one? Impure substance. An impure substance is made up of different types of atoms or molecules. That is, it is made up of two or more constituents. So a formula that shows the relationship between the impure substance, pure substance, and what? An impurity. So you can say that an impure substance equals what? Pure substance plus what? Plus impurity. So what makes a pure substance impure is the presence of what? Of impurity. So examples of impure substance is what? Is mixture. So all mixtures are what? They are impure substance. So mixtures can be subdivided into homogeneous mixture and heterogeneous mixture. So when is a mixture said to be homogeneous? When is a mixture said to be what? Heterogeneous? For homogeneous mixture is a mixture in which the composition is uniform through the mixture. That is, the composition of these mixtures are what? They are in the same phase. Either they are all in solid phase, either they are all in liquid phase, or they are all in gaseous phase. Examples include salt solution. So the solution of salt in water will give us an homogeneous mixture. The solution of sugar in water will also give us what? An homogeneous mixture. Your hair is also what? Also give us what? An homogeneous mixture. Moving to the next one, heterogeneous mixture. This is a mixture in which the composition is what? Is not uniform throughout, and different components are being observed. Examples include when you have a mixture of what? Of oil and water, when we have a mixture of what? Of sand and water, and when we have a mixture in soda like water and water and CO2 gas. So the next one, criteria for purity of what? Of a pure substance. So here we'll be looking at what are the factors to know that this substance is what? Is pure. Number one, it must have a fixed melting point if solid. So if it's a solid substance, it must have what? A fixed melting point. Number two, it must have what? A fixed boiling point if liquid. And if it's a liquid substance, it must have a fixed boiling point. Number three, it must have a spot on a paper chromatography. Number four, it must have a fixed density. And number five, it must have a fixed refractive index. Now to the next one, separation techniques. So what is separation techniques? Separation techniques are those methods that are used to separate two or more substances which are what? Physically combined together. So why do we apply separation techniques? Separation techniques is used to what? To make an impure substance pure. That is, removing the what? Impurity from an impure substance to make it what? Pure. So types of separation techniques. So types of separation techniques that we have are being classified based on the type of what? Mixture that we have. So number one, when we have a solid mixture. Number two, under solid mixture we have sieving, we have magnetization, we have sublimation. Number two, we have what? Solid liquid mixture. We have filtration, we have evaporation, we have centrifugation, we have chromatography, we have crystallization, we have decantation. For the liquid mixture, we have distillation and separating funnel. For sieving, this is a separation technique that is based on what? Difference in particle size. This is differences in their particle size. That is the criteria that we consider before we can use sieving as a separation technique. We look at what? Differences in the particle size of the mixture. Example is when we have our sand and gravels. So we compare the particle size of that of sand and gravel. So that of sand is actually smaller compared to that of gravel. So we can be able to separate them using sieving. Next one is magnetization. Magnetization is a separation technique that is used to separate a magnetic substance from a non-magnetic substance. When we have a mixture of the magnetic substance and non-magnetic substance together, that is, the criteria that we consider is the ability of the substance to get attracted by a magnet. So that's magnetization. Next one is sublimation. Sublimation is a separation technique that will separate a substance that can sublime upon heating. That is, sublime means that it can change directly from its solid state to its gaseous state without passing through a liquid medium. So examples of something that can sublime upon heating now, we have our dry ice, we have our camphor, we have our ammonium chloride. So we have a setup here. So when we heat ammonium chloride, it changes directly to gas. Then when it meets with a cool environment, then it cools down and forms solid. So there we can separate it from the mixture. Next one is filtration. Filtration is a process in which solid particles in a liquid are removed by the use of filter medium that allows the fluid to pass through. That is, the fluid that has been passed through is called the filtrate, but retain the solid particles, which is called the residue. So criteria for filtration is the ability of the liquid to pass through the filter paper. So when we have you can look at the setup that we have here. So what is being collected is called our filtrate. So what remains in the filter paper is called the residue. The next one is evaporation. So evaporation, this is a separation technique that is used to separate solutes from some solvents by burning the solution. It is the solvents get vaporized, leaving back the solute. So these are different techniques to use to separate a solute from a solvent, so that the solvent has the ability to escape. That is, they have the ability to vaporize from the solution. So you have a setup here. When you eat it, then the solute get vaporized, leaving the solvent in the mixture. The next separation technique that we have is centrifugation. Centrifugation is a technique used for separation of particles from a solution according to their size, shape, density, viscosity of the medium, and rotor speed. It involves separation of solid particles that does not settle fast and which are very small inside and cannot be separated by filtration. So when we have a mixture that contains a mixture of solid and liquid, substance, so that the solid substance does not settle down easily. The substance cannot be filtered out. So we have used a centrifugation machine. So the machine is possible to filter it. So examples whereby when you use filtration is when you want to separate your blood cell from your blood plasma. Next one is decantation. Decantation is a process of separating of liquid from solid, another immiscible, that is non-mixing liquid, by removing the liquid layer at the top from the layer of the solid of the liquid below. That is, in this type of separation techniques, you separate liquid from solid, so that the solid substance settle down at the bottom of the separating medium. So you can easily take up the liquid from mixture. You can see that in the diagram above. So the next one is distillation. Distillation is a physical separation based on vaporization of different compounds of the mixture to be separated. Typically, a mixture is heated, vapors are produced, separated, and then condensed back into liquid of distillation by applying it. So when you apply it to it, the solute leaves the solution and form gas. Then this is being collected back using a Liebig condenser into liquid medium. So we have two types of distillation. We have the simple distillation and the fractional distillation. So the criteria we consider in distillation is the differences in their boiling point. So for simple distillation, they have wide range of difference in their boiling point, while for fractional distillation, they have close range of boiling point. If you look at distillation, whereby we apply that in the extraction of our petroleum products using from crude oil, that's about kerosene or diesel, the asphalt and the likes. So next we have separating funnel. Separating funnel is used to separate immiscible liquid. So what do I mean by immiscible liquid? Immiscible liquids are liquids that does not mix together. That is, not mix together. So examples of immiscible liquid, when we have water and kerosene together. So those they don't mix together. So in this type of separation techniques, we consider differences in their density. So the one that is more dense will be below, while the one that is least dense will be above. So from there you can separate the mixture. Next one is crystallization. This is used to separate salts which decompose easily on eating. So this is separation of protein that separates salt that will decompose easily upon eating. So this method of separation depends on the solubility of the salt. So different salts have their rate of solubility at different temperature. For simple crystallization, they have wide range of solubility, while for fractional crystallization, they have close range of solubility. Thank you.